So this is on the proportions of similar figures. I had you draw two rectangles. So I'm going to draw two rectangles right now. What you should understand about these rectangles is that all rectangles have some basic features. In order for objects to be similar, they have to share some commonalities. For instance, usually if you have similar figures, objects that look the same but aren't exactly the same, they usually have angles on the inside. Rectangles have a very unique type of angle. Does anyone know what we call the angle inside rectangles? Yes, Mr. Miller? Oh, absolutely. We call them right angles. I'm going to go ahead and draw those in. You should too. All right, so we have two rectangles, and we're going to label the sides because this is really important. The labeling of similar figures is almost more important than the math behind it. Because when you're looking at proportions, you're making a what? Starts with a C. Oh, say it louder, ladies and gentlemen. Oh, yeah, you're making a comparison. That is the really important part. When you're making a comparison of similar figures, you're making comparisons between sides of the large figure to the small figure. You will always have a larger figure. You will always have a smaller figure. So you're making a comparison between their sides, okay? And when you make that comparison, you have to make sure that you're comparing the same types of sides. So on rectangles, you'd have to make sure you're comparing the long sides, or you're comparing the short sides. We could say we're comparing lengths, or we're comparing widths. On triangles, we would be comparing the shortest side, the middle sides, the hypotenuse, or nooses, or whatever you want to call them. We would be comparing the different hypotenuses of different triangles. So you're always comparing the same type of side of similar figures. So let's label this. I'm going to call this A. I'm going to call this side B. I'm going to call little side X, little side, long side Y. Okay, the littler rectangle, the longer side Y. All right. Now, I'm going to tell you that these two figures are similar. Okay? Which means that the ratios of their sides are exactly the same. Okay? Here's what I mean by that. A ratio is a comparison. So let's say that I want to compare A to B. Okay? Could you predict what the ratio then would look like for the smaller one if I was comparing these? Remember, when we solve or we compare, we're setting one ratio equal to another. So I'm comparing A to B on the left, and that's going to equal some arrangement of X and Y on the right. Yes, Mary? X to Y. Okay, so which one will be on top? X. Okay, X will be on top. Notice which side is on top, the shortest or the longest? The shortest side is on top. Okay, so we're going to put X up here, put Y down there. Notice A then is being related to X. B is being related to Y. Okay, so we see that we are comparing not only sides within the rectangle, but then we're comparing them to each other. Okay, each figure. Yeah, Emma. Yeah, this could absolutely and will absolutely be like finding a missing side. Actually, that's exactly where I'm going to go with this. Okay, so we are comparing similar figures. This is what a classical comparison would look like. I'm not even going to fill in numbers yet. I'm going to show you what this would look like if we were to compare, let's say, triangles next. Okay, so we have the setup for rectangles. Let's switch over now to a setup for triangles. Okay, so I have a simple triangle there. And I have a triangle there. Okay, I'm going to label my smaller triangle A, B, and C. Do you recognize that labeling? Where did we use that same labeling before? Yeah, Ms. Colby. Yeah, the Pythagorean theorem. Oh, my boy Pythagoras. I love my Greek philosophers, okay? So yes, he came up with this great theorem to help us relate the sides. Believe it or not, that's similar to what we're talking about, okay? The Greeks were great at comparing geometric figures. You could even say they're the race or the civilization that kind of developed geometry, okay? Now, we cannot use the same naming scheme as ABC for the large triangle. So let's go, what do you think, Emma? Yeah, I think XYZ would be great. Let's go X, Y, Z. So it doesn't look like a 2. It's a great question. I put lines through the middle of my Z's. I put lines also through the middle of my 7s. Okay?
What number does a 7 look like?
A 7? 7 looks like this.
Well, I mean, like, it could look like a 1.
Because it could look like a 1, yes. Or an L. Or the failed attempt at a very skinny stick figure. Okay, hang on. Let me compare these. I'm gonna kind of fill these in a little bit. I'm gonna tell you first of all that we're gonna compare the small sides to the middle to the longest. And actually, instead of small, let's use the word shortest. That would be a more appropriate use of the words here. Okay, shortest, middle, longest. Okay, what would be the ratio of the shortest sides? Okay, so now I'm comparing, let's call these triangles 1 to triangle 2. Okay, so we're comparing triangle 1, oh, come on now. It's trying to catch up. Give it a minute. Okay, we're comparing triangles 1 and 2. All right, so I would compare A to which side on my larger triangle? Yeah, X. Very good. Okay, so I'm going to compare A to X. Okay, what about the middle? What do we think? What kind of comparison can I make there? Yeah, Chloe? Oh, yeah, that's exactly it. B to Y. And the longest? Yeah, Mary? Yeah, C to Z. Okay. These are slightly different proportions than what we were working for with the rectangles. Could I also go A to B? Could I compare? I can compare anything. So can I compare the shortest and middle side of my triangle 1? I could. And that would be equal to what other type of comparison? Be my shortest and longest side of triangle 2, which would be what, Mary? Yeah, X to Y. Okay, so notice this is a unique comparison. Could I also compare, let's say, C to B? What would that be similar to in my larger triangle? Yeah, Mary? Yeah, Z to Y. Okay, so you have to think about these not as fractions, but as comparisons. Okay, comparisons. I can compare between the figures. I can also compare within the figures, A, B, X, Y. All right? What we find is that with similar figures, all of these ratios allow us to find missing sides. So I'm going to give you an example of this. Okay? Let's say that I have the rectangle. Not quite a good enough rectangle. Okay, I have two rectangles. Let's say they are similar. What you will find in geometry, especially someday, is that you have to identify whether they're similar or not. So I'm going to state that they are similar. There are no assumptions in mathematics. Everything must be stated. I'm also going to label these. And I'm going to tell you the following information. Okay? I'm going to tell you that x is equal to 3, y is equal to 4, and b is equal to 10. And I don't know what a is. But because they're similar, I can figure out a. Could someone help me set up a proportion that might work? I'll tell you there's more than one way to set this up to make it work. Okay? There's more than one way to set this up to make it work. I'm actually going to explore both ways. Okay? Mary. Okay, so I'm going to do a over 3. I'm comparing, therefore, the shortest sides, a and x, and that's going to be equal to what, Mary? Yeah, 10 over 4. Okay, because now I'm comparing the longest sides. Okay, so I'm comparing short sides and long sides. Okay, now this is a little bit of a hard one to figure out. So what could I do, start off the bat? Since I don't see a direct relationship between 3 and 4, what could I multiply by or do to solve this proportion? Emma?
Divide 4 by 3.
I could divide 4 by 3, or I could do this thing that involves, like,
Oh,
oh yeah, cross product, cross multiply. Okay, so we're going to do that. Okay, so I'm going to multiply 3 times 10, and I'm going to get 30. I'm going to multiply a times 4 and get 4a. How do I get a by itself now? Mary? Yeah. Opposite operation. So if they were multiplying 4 times a, if I divide by 4, okay, I can find a. And so what we see happen here is that the 4's cancel out on the right-hand side. And we're left with a equals, let's simplify it. 30 over 4 is going to be the same thing as what? Yeah. Yeah, 7.5. There is another way to set up this proportion, and it'll help us check our answer. Okay, it'll help us check our answer. Here's how we do it. Okay, we look at the same proportions of the figures, but a little differently. Where we compared the short sides between the rectangles, now let's compare within the rectangle. Let's compare x over y to a over b. This is not the same proportion that we did before, but it should still work because we're still making comparisons, okay? This time we're making comparisons of the sides of the smaller rectangle to the sides of the larger rectangle. So this works out to be 3/4 equals something over 10, okay? And we'll call that something a, so that we don't get too confused here. Does that actually end up working out to be the same type of situation? If I cross multiply, look what happens. 3 times 10, 30. 4 times a, 4a. Is that the same thing that I had here? It is the same. I set up the proportion 2 different ways. Once where I was comparing the small sides to large sides, and once where I was comparing the sides of the small figure to the sides of the large figure, and yet the math works out to be exactly the same. So you can actually take multiple approaches to solving proportions of similar figures, okay? There are multiple comparisons you can make, multiple ratios you can form. All right. Not to leave you with too much to think about, but let's go ahead and look at page 183 where your homework is going to be. Okay? There is some notation that you should be familiar with. Some notation, just some of the words that you should be familiar with. Okay? First of all, you should be familiar with the word congruent, which means the same. Okay? I will tell you that you're going to see symbols like the following. You're going to see symbols like this, okay, which represent angle. Okay, so you might see something like angle P. This literally means angle P. You're going to see a symbol that looks like this. That means congruent, which is also basically means that they're the same measurement or the same size. Okay? You might also see something like this, and this I want you to pay very close attention to. Okay? Or you might see something like this. Okay? Please note that what they're doing is they're combining two similar figures in the same figure. So you'll start with, yeah, there's a triangle here, and it is similar to this bigger triangle here. Okay? The same thing is true that you might have a smaller triangle here that is similar to the bigger triangle right here. Okay? So they want you to be able to use figures within figures. All right. Take a look at number 8 in your book, please. Right now, I want you at your table in the next 30 seconds to try to come up with a proportion that will work for solving D in number 8. This is part of your homework, so try it right now, please. Create a proportion that would help you solve D. You have two similar figures. They're not rectangles, they're not triangles, okay? They're quadrilaterals, which means they have 4 sides. How would you solve it? They are similar. They tell you that they're similar. So that means you can make ratios or proportions between the sides. There's 2 ways to solve this. Okay, there are literally 2 ways to solve this. Which one of the ways you could do? Someone want to offer up a suggestion? Emma. Okay, but let's set up our ratios first.
It would be 16 over 9 to D over 18.
Okay. That is definitely one of your options. In this one, she's comparing small sides on top and large sides on the bottom. Before I begin, or actually let's go, so you could do this. You could cross multiply and solve for D. What is another way you could set that one up? There's one more way you could set it up. Yeah, Mary?
16 over D
Yep.
equal to 9 over
9
18.
over 18. Look, the cross multiplication would produce the same math. You're still going to multiply 16 and 18. You're still going to multiply D and 9. But notice that the comparisons I've made were slightly different. In one side, I was comparing small figure to large figure. Okay, that would be this one here where I have the large figure and the small figure. And over here, I'm comparing large side to small side. Okay, notice here I'm comparing sides. Okay, and then of course you guys could go ahead and do the math because this is similar to your previous lessons.